In our last section, we will be talking about how we research motor development. So the big thing that we typically look at is something called a developmental trajectory. And basically what this is it's a graphical representation of changes in development over time. So age or some type of unit of time is usually going to be on the x-axis. And then the characteristic that we're observing the developmental trend in would be on the vertical axis. So this is kind of just a unitless example where we have some characteristic with these units on the y-axis and we have our age on the x. And then these are the different possible trajectories that you might see. So the first type of trajectory is average development. Okay, and we're using a linear trend just to keep the example on the simpler side. But when we look at different developmental trajectories, usually there's an average line or an average kind of window that we would expect to see at different age groups. The next type of trajectory we would see is advanced development. So somebody who has a higher level of performance in a certain characteristic, or let's say this was a height chart. Height charts are not linear, but for the sake of the example, somebody who is taller than the average person at the same age. Okay, so trajectories above the norm are advanced development. Trajectories below the norm would be delayed development. So I am a prime example of a delayed developed child. I was the size of a 6-year-old when I was 12, and I just didn't hit growth spurts ever. So with respect to other 12-year-olds, I was extremely short, and that would be an example of delayed development. Now this last line on our graph, you see there is a plateau in which we see development stop after a certain point. That is arrested development. Okay, so arrested meaning it has been completely halted and it does not go up or down past a certain point. Okay, there's a different type of developmental trajectories, and developmental trajectories can be studied with various types of study designs. The most accurate, but yet most time-consuming study design is longitudinal research. So think long is in the word longitudinal. It's looking at an individual or group over a long period of time. So if we collected a bunch of 2-year-olds and we were looking at one developmental characteristic through their early childhood up until all of them turned 10, we could then see what the progression in that developmental characteristic is through this period of time. Now, because longitudinal research is very time-consuming, oftentimes researchers will opt to do a cross-sectional research study design in which they take people of different age groups and they observe them one time. Okay? And then we're kind of inferring that we have a certain developmental trend, but we're not actually observing it. So in this case, maybe we take a group of kids who are 3 to 5, 7 to 9, 11 to 13. It doesn't even have to be age groups. It could just be, let's take a group of 3-year-olds, a group of 5-year-olds, a group of 6-year-olds, 7, and so on and so forth. But the fact of the matter is you're taking different samples of people who have different characteristics, and then you're looking at how are these ages or age groups different from each other, and that's how you build your developmental trajectory. Again, the change that you see or the pattern that the trajectory takes is going to be inferred development. It's not directly observed. Some people will opt to take a combination of both longitudinal and cross-sectional, which we often call sequential or mixed longitudinal study designs. So this is when you have an individual or group who who are observed for multiple dispersed short periods of time. Okay, so let's say we take people and we want to do an observation of a certain developmental characteristic every 2 years. Okay, so now we're kind of taking the idea of age groups, or where we have split sessions, but we're still tracking the same person over an extended period of time. Okay. So this is kind of what the model of a sequential research design would be. These are the cohort years that people were collected. So let's say group A, we collected them at 5 years old. We had a group then at 10 and a group at 15. Okay, so this is kind of the concept of using like a cross-sectional design, but then we follow those age groups over time. So eventually this age group 5 will become 10, and then we can mix our 10-year-olds of that group with the 10-year-olds that we started with. That 10-year-old group will then become 15, right? And then we can compare them with the 15-year-olds we initially started with. So different ways that we can look at people. Either we're chunking them, like let's say we have group A 5, group B are 10, that would be cross-sectional. We could look at people as they age over time. That would be more of a longitudinal design. And then if we had a sequential design, we could either track the same group of people at dispersed time points, or we can have groups and track those groups at dispersed time points. When we look at developmental trajectories, we notice that there is a paradox in development, and this is largely due to 2 things: universality and variability. Universality is the concept that individuals in a species show great similarity in development. So this is the age-related concept of development, where certain age groups should be expected to have similar developmental characteristics. However, as we talked about in the age-related part of our development definition, there's also a lot of variability, right? Because each individual is going to develop at their own rate. Development is subjective, even though in the grand scheme of things, there is a sequential order that things happen in. So while we can expect certain developmental milestones to occur around a certain age, there still is a lot of variability based on the individual. All right, so that concludes our lecture videos for Module 1. I would recommend you go back through the videos and or go back through your notes to prepare you to take Quiz 1, and then you'll get a bit more practice on some of these concepts working in Activity 1.